Welcome to the last lecture of week 8. We are discussing welding technology in week 7 and week 8 of the course Basics of Mechanical Engineering 2. I have discussed the problem statements on welding in the last lecture, and also I have discussed certain characteristics of the welding arc. Now, in this lecture, I will demonstrate the simulation, the virtual simulation on the welding, which is developed by the VLab, and for that I will come to the Google page and I will type here VLab welding, enter. The first link that comes is welding lab. Let me click this link. So I have now a page opened which shows virtual lab developed by an institute, and here are the list of the experiments. That's just zooming it out. Study and design of weld joints, heat flow across the weld bead, principles of gas welding and gas cutting processes, principles of shielded metal arc welding, effect of welding parameters on weld bead, principles of metal inert gas welding, principle of tungsten inert gas welding, principle of submerged arc welding, weld zone evaluation, non-destructive testing of welded joints, and advanced welding techniques. Because this is a basics course, I will not talk about weld zone and heat affected zone, etc. I will just walk you through certain welding processes. Majorly, the gas welding you have discussed in the previous lectures, all of them are those discussed, but I will more focus this virtual laboratory demonstration on the arc welding and some of the advanced processes. Now, first I will come through metal arc welding. I will just click the link and we are opened with the demonstration page here, where we have aim, theory, pre-test, procedure, simulation, post-test, references, contributors and feedback. This is the generic page for virtual laboratory that you have seen in the previous lectures as well. So aim is to understand the basic principles of shielded metal arc welding process. Theory regarding the shielded metal work, regarding the shielded metal arc welding that we have discussed is again represented here. So what is SMAW, covered about the flux and all the layers of the weld zone. It is presented here. The slag layer is there because we have the electrode here with where the core is the metal, and outside we have the flux coating on the metal. Flux covering is there, and this flux covering makes slag and weld buildup is there. In between the weld buildup and the weld metal, we have the weld depth of fusion. So all these components, all these parts are here of the weld zone. Then there is a theory regarding the different positions: flat position, horizontal position, vertical position, overhead position. These are the positions where the submerged metal arc welding could be taken. Process parameters could be electrode diameter, electrode type, welding current, welding speed, arc length. Welding equipment includes the power supply, electrode, electrode holder, ground clamp, welding helmet, welding cables, chipping hammer and wire brush to clean the slag later. Advantages and disadvantages are given. Theory part is covered already. Let me come to the pre-test questions. The first question is, what does SMAW stands for? This is shielded metal arc welding. What type of joint can be made using SMAW welding? There could be multiple joints: butt joint, lap joint, T-joint, all of them could be made. Type of electrode used in SMAW welding. The electrode used is generally a stick that is having metal at the core and there is a coating of flux outside. The power source that is used in SMAW welding is both DC and AC power could be used. The purpose of flux coating in electrode in SMAW welding is to protect the weld from oxidation, yes, to provide this shielding gas, to improve the mechanical properties of weld. All of these are the purpose points. What type of metal can be welded using SMAW? It can weld steel, aluminum, copper. All of these could be welded. What is the major advantage of SMAW? Speed, portability, automation. Automation is generally not there because big and TIG welding are there that has more automation. A continuous supply of wire is there. So automation is less there. So that is not an option. Because automation is not there, speed can also not be an option. Portability, because power supply is a small equipment that can be taken to any place. So that is the portability is major advantage here. During DC SMAW, which polarity concentrates more heat on the electrode? because it is direct current. So direct current, reverse polarity is used. What type of groove is constructed for vertical position welding? For vertical position, V groove is constructed. Which of the following defect can result from using wet or damp electrode? Porosity could result. Lack of fusion, slag inclusion, undercut. Porosity is the major answer here. Let me submit it. I got 10 out of 10. So that means all are correct. The procedure is mentioned here now. The next step, that is, we press the start button, then select the type of operation of your choice, type of joint, type of material, start button to start the process. Then mouse can control the scroll for zoom in and zoom out. Left click and move mouse to rotate. Right click and move to move the setup. Repeat the experiment. This is kind of a simulation that you see in various CAD softwares, computer aided design softwares, where you try to drag the figure from one place to another, the animation or figure that is there, or you try to zoom in and zoom out, or you try to move the overall figure from one point to other. Those all controls are given here. Let me come to the simulation. The procedure is again given here, and the first step is to press on the start button. Start button, type of operation, there is only one choice here, shielded metal arc welding, and click here. Type of joint, that is, there is butt joint, there is only one selection point. Type of material is mild steel, and I can start here. Now here is the simulation. I can zoom it out. It is showing the butt joint completed here. This is simple, I would say, simulation or animation here, but we can keep picking different options. If not in this experiment, in multiple other experiments, different options could be chosen. Now the next step here is post-test questions. I click on the post-test, they are post-test questions. What is the typical weld position used in shielded metal arc welding? Typical weld position that is used here is, this should be all of these. The second question is, what is the typical shielding gas used in shielded metal arc welding? Argon, carbon dioxide, oxygen. Other three are not the right answers. Next question is, what is the purpose of slag in shielded metal arc welding? The purpose of slag is to protect the weld from atmospheric contamination. How arc is generated in SMAW? Arc is generated by striking the electrode against the workpiece. The first answer is correct, by using a non-consumable tungsten electrode, by using wire electrode, by using a gas shield to ionize the air. Other three are not the right answers. How does the electrode coating affect the welding process in SMAW? It affects the melting rate and deposition rate of the electrode. This is the effect it creates. Which of the following is not a type of electrode coating? Electron coating is of multiple types. It could be rutile, no. Calcium fluoride, no. Cellulose, no. Nickel coating is there. Chipping process after SMAW is done to remove the slag. Which of the following type of materials cannot be welded using SMAW technique? High melting point, low melting point. Low melting point materials cannot be welded because the temperature of the arc is very high. Low melting point materials are generally soldered. So high melting point materials are only welded using SMAW. The last question in post-test is, which of the following welding positions electrode is held at 45 degree to the workpiece? So in the horizontal position, electrode is held at 45 degree. I will submit it. So I got 9 out of 9. Next is references which were used to develop this virtual laboratory demonstration. Welding Handbook, Welding Science and Technology by American Welding Society. Robert V. Metzler Jr., Principles of Welding Processes, Physics, Chemistry and Metallurgy and Manufacturing Science, second edition by Amitabh Ghosh and Ashok Kumar Malik. So this was one of the experiments. Let me try to pick another experiment. Next, I will try to pick any of the automated welding processes. Let me, for example, pick metal inert gas welding. So this is similar to the shielded metal arc welding. Only the point is the wire is fed continuously and there is a gas around. So theory here, this is how it works: inert gas supply, contact tube, gas nozzle. This is a mixed setup, and this is the mechanism within the nozzle. There is a gas diffuser, there is a gas nozzle, the wire guide and contact tube is there. Solid wire electrode comes out of the wire guide, and this gas diffusion tries to shield the welding zone from the outside atmosphere. So weld metal is there, that is put here, and this is the base metal, molten metal pool is there. So this theory about the gas metal arc welding or the metal inert gas welding is given. The kind of the metal transfer processes could be short circuit transfer, could be globular transfer, could be spray transfer, pulse transfer. This is given here. Different kinds of the metal transfer processes are further explained here, and the constant voltage power source that is used, that we have discussed, how the current varies with the fluctuation in voltage, that is given here. And let me come to the pre-test questions before talking about the simulation. What is gas metal arc welding or GMAW used for? Joining metal sheets, welding pipes, welding non-metallic materials. C cannot be the answer. So both A and B are the answer, that is joining metal sheets and welding pipes. What is the purpose of shielding gas in gas metal arc welding? Shielding gas protects the weld from atmospheric contamination. C is the answer. Controlling temperature, providing filler metal is not the purpose. How is the heat used to weld by GMAW process generated? How is heat generated? Heat is generated with the help of electric arc. So B should be the answer. What is the gas used in MIG welding? Gas used here is majorly argon. What type of electrode is used in GMAW welding? Electrode that is used is the consumable electrode. Which of the following gas is not used in GMAW? Argon is used. Helium could also be used. Acetylene is not used. Acetylene is used in the gas welding technique, and we can only use the inert gas, argon or helium. Which of the following types of metal transfer provide lowest amount of heat to the workpiece? Spray transfer, short circuiting transfer, globular transfer, pulsed arc transfer. Short circuiting provides the lowest amount of heat. In GMAW, what is the primary material of the consumable electrode for welding carbon steel? For welding carbon steel, mild steel electrode is used. Submitting the quiz and then coming to the procedure to understand how do we run the simulation. It is similar to what we did in the shielded metal arc welding. Start button, then type of operation, type of joint, type of material, type of electrode, then again start. The mouse controls are the same as we saw in the previous setup. Simulation, coming to the start button, clicking, type of operation MIG, type of joint butt joint, type of material mild steel, type of electrode is again mild steel, and I can start my simulation here. So this is the simulation that is represented here. You can see here. So this is the welding that is completed. So this is the simulation here. This is the whole system or equipment kept here. So let me stop. Just to show you once again, I select the different variables and start the process. You can see the nozzle is supplying the electrode material and the welding material in the form of wire, and it is being transferred here, and this is what we have gotten is slag over the weld. Next is the post test questions. The post test questions, what does GMAW stands for? It is gas metal arc welding. Which of the following metal transfers mode can occur during MIG welding? Globular, short circuit, spray, all of these could occur. What is the main advantage of GMAW welding over the other GTAW systems? The advantage is high metal deposition, lower cost, better penetration, all of these are advantages. What is the use of shielding gas in GMAW welding? It prevents oxidation. Yes, increase heat of weld, make the weld stronger, cool the weld. No, these are not the options. It prevents oxidation. Which of the following shielding gas is typically used to achieve a shallower penetration in GMAW welding? For a shallower penetration, we use carbon dioxide. However, argon, carbon dioxide, helium, oxygen, all of them are used. Argon is majorly used, but for the shallower penetration, if it is there or if it is a requirement, carbon dioxide is used. What is the effect of using a higher voltage in MIG welding? When using a higher voltage, larger weld bead is created. How does using a larger diameter wire affect the MIG weld? It improves penetration, because if the diameter is higher, the overall bead size becomes bigger. What is the effect of using a lower amperage in MIG welding? If the current is lower, we get shorter weld bead. For consistent arc length, which type of power source is used by GMAW process? This we have discussed in the last lecture. Constant voltage power source for self-regulating is used for having a consistent arc length. In which of the following metal transfer modes, metal transfer in the form of large droplets to workpiece is there? In the form of the large droplets, if we say, that is there in the globular transfer method. Which of the following shielding gases are used for welding the various carbon steels? Argon or carbon dioxide? Submitting, got everything correct. Now, this is again developed using certain references and contributors are there from the developing team. The certain other experiments available like tungsten in gas welding, submerged arc welding, those are similar to what we have seen now. Let me see something different now. Let me try to see the testing of the welding joints, the non-destructive testing. Here the objective is to study and understand the various non-destructive tests of welded joints. Theory, different kinds of tests. It is non-destructive testing that is there. Non-destructive means there will be no effect on the welding or the welded material. Only the dye penetrant test could be there, which could be surface penetration, so that we see any voids etc. in the welded joint. Penetrant application, removing extra penetrant. This is the procedure how it goes. This is how it is penetrated here. The liquid is penetrated here. I mean, try to see or try to have the image while passing light through this. So then ultrasonic testing is one of the methods using ultrasonic principle, because the pulse, it goes inside and come out whenever defect is there. For example, if here defect is here, the ultrasonic wave will come back early. So this is ultrasonic testing method. Then magnetic particle testing. Magnetic bar magnet are used. The flux leakage is there whenever a crack or some welding void or something is there. So these tests could be taken. This is a simple theory on welding tests. Pre-test questions. Which type of the following testing techniques is non-destructive? Metallographic, ultrasonic, hardness, tensile. Tensile, hardness, metallographic are all destructive tests. Tensile test, we break the material. Ultrasonic test is non-destructive. Non-destructive testing method will not cause any damage to the sample that is being tested. This is true. Which non-destructive test uses sound waves to detect defects in the material? As I have discussed or I have shown you in the theory, ultrasonic testing sends the sound waves to detect any defect. Which of the following tests are not non-destructive? Radiography, hardness, acoustic, magnetic particle test. Hardness is a destructive test because it creates an indentation over the workpiece, which for that is the surface roughness of the workpiece is also hindered here. Which of the following materials are ferromagnetic? Magnesium, molybdenum, copper, zinc, cobalt, nickel, silver, gold. Here copper nickel combination is ferromagnetic. I submit. Let me come to the procedure. They say start button, non-destructive testing, pick the test, ultrasonic testing, dye penetrant test or magnetic test. For each of them there is a separate set of instructions. For ultrasonic testing, we observe the transmission pulse flow, we observe the ultrasonic device monitor, press the next button to go to the next case and restart. In dye penetrant test, welded workpiece, we press next, penetrant bottle. Let me try to come to the simulation, and instructions are already still given here. I will start. I will pick first the ultrasonic testing. See, it is showing the ultrasonic waves coming and going. So transmission pulse, first pulse set, all good. Next, second pulse set, and while sending the second pulse, we saw that the time is reduced. So that is defect echo is here. Next, another pulse sent. The transmission pulse, defect echo come in between, and back wall echo is also there. Again, next, we start from the beginning. Here is no echo, no defect echo. In the second step or second sending of the wave, the ultrasonic device monitor shows the graph here where intensity is given here and the time when the wave is sent, it is also given. It identifies a defect echo here. This is how it goes. So this is ultrasonic testing. So let me take another test. I'll now again start and I will now pick dye penetrant test. So I'll click start and click next. So penetrant, this is a penetrant spray. I will click on the penetrant and this penetrant would spray over the welded zone, the welded workpiece. So it is now being penetrated down to the crack. Now there is liquid penetrant there and there is a cleaner of the penetrant. I will click the cleaner, it will remove the excess penetrant, and using the cloth excess penetrant is cleaned. After excess penetrant removal, we put the developer over it. This developer will now let us know where the crack is. The crack indication is here. The developer comes out and shows that here is a crack. So this is how dye penetrant test is there. We can restart to understand it. So we click the penetrant is sprayed and then it is cleaned, and developer helps us to understand where the crack is. So this was the penetrant test. Next, I will come to see the magnetic particle testing. Right, I'll stop it here and again start magnetic particle testing. Magnetic particle testing without crack and with crack, both of the options are there. Let me first pick without crack. I will say next. This is ferromagnetic particles which are sprayed here, and using a magnet here, it is identified that no crack is there, that is no disturbance in the magnetic field is there. Let me restart and let me pick the MPT with crack and try to go to click next here. Here, after spraying, you see if the crack is there, there is a change in flux. The flow of the lines, magnetic field lines are showing change here, that is crack here. So these were all non-destructive testing. So these are taken care or carried out using a specific equipment, that could be for magnetic testing, that could be for penetrant, or that could be for the ultrasonic testing system. And these are generally used to identify the cracks. When we try to do any testing on the materials, if it is non-destructive, 100% testing could be taken. That is, all the systems, all the material, the components which are manufactured could be tested, because there is no hindrance, there is no destruction of the material. If it is a destructive testing, for example, tensile test, hardness or so, we have to only pick some sample out of the 1000 pieces which are manufactured. If tensile test is to be taken of the welding, then some out of the 1000, make example 10 out of the 1000 only have to be picked, because those will not be usable later. So that is difference between destructive and non-destructive testing. Let me pick another experiment. Let me pick submerged metal arc welding. In submerged metal arc welding, the objective is to understand the working principle of submerged arc welding and its various parameters, theory about the submerged metal arc welding, when the wire reel is there, flux hopper is there, so that a continuous supply of flux is there, so that the arc is completely submerged under the flux. See how it looks like working of a submerged arc welding. Liquid weld metal, weld pool and weld material are there, solidified slag is there. This is a flux feed that is there separately, so that it is a submerged and it is completely shielded from any impurities, any effect of the atmospheric conditions. So there is a equipment, that is electrode wire, wire feeder, welding charge, flux, etc. Applications are high deposition rates, deep weld penetration. Flux prevents weld spatter, resulting in clean and sound weld. Edge preparation is not necessary. 50 to 90% of the flux can be recovered, repurposed and utilized again. Submerged arc welding is easily automated, making it an ideal choice for high volume welding applications. Let me come to the pre-test questions. Which of the following is the correct full form of SAW? Submerged arc welding. The A is the right answer. Which statement regarding submerged arc welding is correct? It uses consumable electrode. Yes, it uses consumable electrode. It requires shielding gas. No. It is form of gas welding. No. It produces high spatter. No. It uses consumable electrode and spatter is minimal because it is submerged. The arc is submerged under flux. Which of the following industries commonly uses submerged arc welding? Automotive, aerospace, shipbuilding, electronics. Shipbuilding majorly uses the submerged arc welding. What is the purpose of granular flux in submerged arc welding? Granular flux is used because weld is to be protected from contamination. Submerged arc welding, the welding arc is exposed to the surrounding atmosphere? No. Protected by a shielding gas? No. Completely submerged under the flux layer? Yes. Generated by a tungsten electrode? No. So the answer is completely submerged under the flux layer. I submit this and let me now come to the procedure for the simulation. It says press start button, type of operation, type of joint, type of material, type of electrode, type of flux is picked, and we start the simulation. Click the next button to start the process of welding. Let me come to simulation. Let me click the start button. It asks me to click on the submerged arc welding, butt joint, mild steel is the material, electrode is also mild steel, and type of flux is also picked here, that is silicate based flux. I start it here. I start the welding. So it is showing the whole equipment, the reel of the wire field, the flux supply, and the system that controls generator and everything. I click the next button to start the welding. So this is how the welding goes, and it comes back to the original position. Now using the hammer, the flux is removed and this flux could be reused here. In submerged arc welding, the welding current is primarily responsible for generating heat to melt the base metal and filler wire. Yes, it is the primary purpose. Controlling the speed, providing shielding gas, controlling the arc length. No, generating heat is the primary purpose of welding current. Extremely low welding current may lead to, extremely low welding current means insufficient penetration. Narrow weld bead, increased porosity, cracks in the weld bead. Insufficient penetration is the answer, that is closer. Purpose of controlling the arc voltage in submerged arc welding is to regulate welding speed, maintain stable arc, adjust the electrode size, control electrode consumption. The right answer should be maintain stable arc voltage. Submerged arc welding is suitable for welding thick metal plates. Larger diameter electrode in submerged arc welding produces, if larger diameter is used, higher deposition rate is there, deeper penetration, both of them should be correct. So both A and B are the answer. Copper coating of the electrode wire is done to increase heat and resistance, make it shiny, increase conductivity and corrosion resistance. Yes, this is the right answer. Increase conductivity and corrosion resistance because copper is highly conductive. So copper coating of electrode is done. Extremely low welding speed leads to, extremely low welding speed in submerged arc welding, if it is there, it can lead to inclusion of slag. Current density in submerged arc welding is determined by the electrode diameter. Which of the following factors determines the appropriate welding current for submerged arc welding? Thickness of base metal, welding position, type of flux used, all of these determine it. So these are all marked correct. So this was submerged arc welding. Let me now pick another experiment. I will just try to pick here is advanced welding techniques. Just walk through the different techniques which are given here. In the theory, we have been given laser welding. The principle of laser welding is given. Then we have been given the friction stir welding using a fixed stir the welding is done here. And we have the pre-test and post-test question for them. What type of welding process is friction stir? It is a solid state welding. It is just due to friction, no fusion, no resistance, no gas is used. What is the main principle behind friction stir welding? It is the heat generation through friction, that is through rubbing. What is the temperature range during friction stir welding? Temperature range is not very high, that is below the melting point temperature. The next questions are all about laser. Which of the following is true with friction stir welding process? It is having a minimal heat affected zone, it reduces residual stresses, it has both A and B, that is has minimum heat affected zone and reduced residual stresses. Which of the following defects in friction stir welding process is related to tool plunge depth? Porosity, cracks, distortion. Distortion is the right answer. So I can submit the quiz, the marks would be less. Whatever questions I have marked are correct regarding friction stir welding. I am missing here the laser welding because the laser will be discussed in the forthcoming weeks, where we will discuss about the advanced processes. There the laser welding, laser machining system would be discussed. Now procedure for friction stir welding, we select the following steps: rotation speed, we select the weld speed, we click the submit button, we observe the torque calculated, we repeat the experiment with different values and try to understand how the friction stir welding is going on. Let me come to the simulation here. In the simulation, I will pick friction stir welding, and here I can pick different options from the given rotational speed, that is RPM 250, 500, 710, 1000 and 1400. This is rotational speed of the motor. Then weld speed, that rotational speed of the motor is one parameter. Weld speed, that is the speed of the movement of the motor along with the weld line, that is there. So weld speed could be any range between 0 to 450. Suppose if I pick a very small value here, for example 50, and I submit it here, you can see the motor speed is 250 and at the weld speed of 50 millimeter per minute is going on. It is started here. Because the speed is slow, it is taking time for the welding to go through. Let me now increase the speed. Let me say I increase the speed to 400 millimeter per minute, and also I will increase the rotation speed of the motor. Let me say I will put it to 1000. Let's submit. You can see now the motor is also rotating fast and the welding is also getting in a faster speed, that is at the speed of around 400 millimeters per minute. This is friction stir welding. Now let me come to the post-test questions only about friction stir. What is the purpose of rotating tool used in friction stir welding? It helps to generate heat, it helps to generate pressure over the weld zone, it helps to generate friction. All of these are the answer. In conduction welding, what is the main advantage of friction stir welding over traditional welding methods? It lowers the welding temperatures. It happens at the lower welding temperatures, higher welding speed, higher quality, all of the above. No, it happens only at lower welding temperatures. The size and the shape of the weld material in friction stir welding depends on which of the following parameters: the size and the shape of weld material. Tool tilt angle, tool plunge depth, tool rotational speed, pin profile. Tool tilt angle determines the size and shape of the weld material. Then comes friction stir welding. Tool is made up of which material? It is made up of a material that is hard and it should be wear resistance, because all the time it has to generate heat using friction only. So I will submit only the friction stir questions, and all these questions are marked right, and I can also see the explanation. For example, for the tool tilt angle, yes, you are right, this is only the explanation given. So this is regarding the advanced welding techniques. One last experiment I will like to walk you through is not any other welding process, but I will try to study the characteristics of the weld bead. Let me pick this experiment. Effect of welding parameters on weld bead. To understand the effect of different welding parameters on the weld bead profile. Theory. Weld bead, what is the construction of the weld bead? So bead width, heat affected zone, base material, reinforcement height and penetration depth, all of the different dimensions are given here. So theory about the welding bead, that take effect of welding current, effect of welding voltage, effect of welding speed, effect of electrode diameter. These are the 4 parameters that determines the bead size, shape and quality. Welding current, welding voltage, welding speed, electrode diameter. Let me come to the pre-test questions. Welding current controls melting rate of electrode. The change in welding voltage is determined by the change in arc length. Increased welding speed reduces heat input. Yes, it reduces heat input. Increased heat input does not affect the heat input. The correct answer is it reduces the heat input. Variation of electrode diameter, it does not impact the weld bead geometry, not correct. Impact weld bead shape, yes, variation of electrode diameter, for the more diameter or bigger diameter, weld bead shape would be larger. Welding parameters affect weld quality, weld shape, both A and B. Heat affected zone is majorly depending upon which of the welding parameter. Heat affected zone is majorly depending upon the welding current. What type of power supply has higher heating rate? For higher heating rate, DC power supply is used. Melting, the base material increases as the welding current increases, the welding current decreases. Does not happen on the variation of welding current. As the welding current increases, the melting of the base material increases. I'll submit the quiz and I'll now come to the procedure. It says choose arc voltage between 16 to 21, choose arc speed in millimeters per minute between 0.3 to 0.5, choose arc current in amperes between 320 to 400 and click the submit button. Simulation. Start. I'll pick arc voltage. Let me say I'll just pick alt voltage as 19 volts. I'll pick the speed or put the speed as 0.4. So I'll put the arc current in amperes. I can also click this button to come to the current that I would like to put here. I will put the current in amperes, maybe let me say only very small, 30 amperes. Submit. So it will show how the weld bead geometry would be generated. Right, reinforcement zone is blue, penetration zone is orange. Now if I change the parameters, for example, if I change the arc current, if I suppose increase the arc current to 300, I submit. You see, this is how the weld bead is generated. Bigger bead has come. If I suppose put this value as 400, increasing the current, submit, you can see the larger bead is generated. It is showing exact dimensions here. Plate width, that is the bead size is around 10 plus 20 plus 2 on 2 this side, around 24 millimeter of the diameter of bead is there. So bead dimensions are given exact here. For instance, if it is from point number 28.2 to 51.5, so around 24 millimeters of the bead width is there, and bead depth is also there, a thickness. For example, if I try to see this parameter, this point is 30.0097, the yellow color that you could see, and the above point is the blue color that you could see is 42.51. So that means around 12 millimeters of the depth is there of the bead. So for different parameters, this is simulated while taking experiments at different parameters, or while using the theory, the formula is used to develop this simulation. So let me now take the post test questions here for the weld bead parameters, and I'll close this lecture. The post test questions are also giving the understanding about whatever we have understood about the arc welding throughout the last 2 weeks. So welding issues due to weak welding current are poor penetration, unstable arc. Both of them are the issues. Arc voltage beyond optimum value generates, if it is beyond optimum value, it will generate a broader bead. Increased welding speed can cause reduction in amount of filler metal, undercutting, narrower weld bead. Increased welding speed can cause all of these. Reduced welding voltage generates intense arc, deeper penetration. Both of them are generated with reduced welding voltage. Intense arc could be there, deeper penetration could be there. Slow welding speed allows molten gases to escape, lowers porosity. Both of them are the output. If the slow welding speed is there, it allows molten gases to escape, the porosity lowers. Faster welding speed, exactly contrary to the slow welding speed, the faster welding speed generates smaller heat affected zone. Unreasonably high welding voltage can result in, if the voltage is very high, that is unreasonably high, then cracking could be there, more difficult slag removal could also be there, reduced porosity by rust on steels could also happen. That is, all of these are the correct answer. Low welding current can cause, it can cause unstable arc, it can cause poor penetration. These defects could be there. For welding thicker material, electrode diameter should be, for welding thicker material, because the material is thicker, obviously the diameter would be larger. Which of the following is the reason for cracks and undercut in weld bead? Higher welding voltage. Cracks and undercut are there because higher welding voltage is there and there is not enough current to compensate, and the bead is full, not also created, and there is a void or crack that is generated. When welding thin sheets, a key parameter to control to avoid burn hole is welding current, travel speed. For thin speeds, travel speed has to be optimum so that no burn hole is generated. I submit the quiz and I got full marks here because I practiced this quiz before as well. Now, these are the references, certain books, certain handbooks and certain research papers might have been referred to develop this whole simulation. So, this was about the virtual simulation of welding. In the coming weeks, we will take metal cutting, that is machining. Then we will go through the advanced manufacturing processes, and then some concept of sustainability would also be discussed in manufacturing. Thank you.